Today, we will talk about the sulfur conversion rate during the coking process. That is, the sulfur contained in the coal charged into coke oven that ultimately ends up in coke after carbonization. People in this industry generally believe that this is not something that can be calculated precisely. Therefore, most practitioners remove the highest value and the lowest value, and then take the average as a basis for estimating the sulfur conversion rate to guide production. Because of this uncertainty, it actually has a significant impact on our production costs and can also cause errors in the production process. Sometimes everything seems fine, but the sulfur in the final coke turns out to be too high, resulting in penalties. On the other hand, scholars have long been conducting research on this issue. We often see many scientists and academic researchers studying the sulfur conversion rate in coal. They continuously analyze the different forms of sulfur in coal, including pyritic sulfur and sulfate sulfur, as well as sulfur in aliphatic structures and those in aromatic structures. They carefully study the molecular structures of these sulfur species and occurrence modes through countless experiments and statistical analysis. Eventually, the complexity can become overwhelming. In our view, regardless of the form of sulfur in coal, when the coke oven temperature reaches above 900 degrees Celsius, most of the sulfur will decompose from coal and become gaseous sulfur compounds. Then the question is, how much of these gaseous sulfur compounds enter coke oven gas, and how much ends up in coke? The key lies precisely in this stage, where the volatilized sulfur inside the coke oven undergoes further reactions through a series of chemical processes that can be listed and systematically studied. Among the various sulfates produced by these reactions, those that do not decompose at the highest oven temperatures will retain their sulfur in the coke. Conversely, those that volatilize again will enter coke oven gas. If we can list all of these reaction processes and equations, we can determine how much sulfur exists in coal in total, and how many other elements are available during the reaction to combine with gaseous sulfur and form saturated sulfate compounds. First, we need to compile the volatilization temperatures of different sulfate species. Then we identify those whose volatilization temperatures exceed the maximum oven temperature. In this way, we can accurately calculate the sulfur conversion rate of coal charged into the oven. Now let's make a comparison to see how it works. Here I selected 4 coal grades, including 2 kinds of gas coal and 2 kinds of fat coal. The basis for this selection is that during the calculation using the chemical equations we discussed earlier, these represent typical examples with relatively high and relatively low sulfur conversion rates. Let's demonstrate with gas coal as a comparison. We selected Huairen gas coal and Ningwu gas coal. These are very familiar coal grades, especially in North China, and are widely known among coke producers in Shaanxi. If you have had practical experience before, you will understand. If you have not, you may verify it yourself later. First, we take Ningwu gas coal at 100% in a single coal blend. We can see that its sulfur content is 0.33%. Its ash content is not that low. The current contract specification is usually 9%. Now let us calculate its sulfur conversion rate. After calculation, we obtain the result. We see that the sulfur conversion rate is 1.36%. Normally we believe that if coal contains 1% sulfur, the sulfur content in the final coke will be about 0.9%. However, Ningwu gas coal is a rather extreme example. Its conversion rate is 1.36%. That means when the sulfur content in coal entering the oven is 1%, the sulfur content in the final coke is 1.36%. It increases. Now let's apply the same method to examine Huairen coal. We also 100% use Huairen coal. Then we check its sulfur conversion rate. It's 0.92%. That means when the coal sulfur is 1%, after coking, it becomes 0.92% in the coke. This is consistent with the normal understanding in the industry. Now let's see why Ningwu coal has such a high sulfur conversion rate. It is hard to find one coal grade in Shaanxi with such high levels of calcium, magnesium, and iron. These elements form calcium sulfate, magnesium sulfate, and iron sulfate. These compounds have high stability under high temperature. In particular, they can combine with silicon and aluminum to form even more stable complex salts, which remain stable at temperature above 1200 degrees C. They do not volatilize. Many other sulfates, even if they form initially, will volatilize once temperature reaches 1200 degrees Celsius and return to coke oven gas. Therefore, those alkaline elements capable of forming high-temperature, stable sulfates can refix the free sulfur in the coke oven into coke, resulting in the high sulfur conversion rate of Ningwu coal. Due to time constraint, we will not compare the fat coals today. If you have any questions, please contact Sxcoal customer service or send me a private message. See you next time.